Welcome back to my channel. In today's lesson, we'll be looking at 2025 Waec volumetric analysis. But this video will focus more on alternative to practical, as we all know that when it comes to volumetric analysis, after carrying out some series of tests, you must have a table of value, which we are going to look at tonight. And guys, if you have to look at this table of values on the whiteboard, I'm having two tables of values. But before then, A is a solution according to the report given to each schools. So A is a solution containing 0.10 mole per dm cube, and that A is hydrochloric acid. B is a solution containing sodium bicarbonate. Now, if you have to carry out the practical in the lab, A, which is the HCl, don't forget the acid will run into the burette. And this particular practical, the indicator to use is methyl orange. So guys, when we come to this white practical for 2025, I'll be looking at 4 different things you are going to calculate on. The first one is concentration of B in mole per dm cube. The second one is concentration of B in gram per dm cube. The third one is concentration of A in mole per dm cube. And the last one is volume of carbon dioxide gas produced at STP. So if you are given a question like this, how do you tackle such correction? So now, come closer. As Waec candidates, please come closer. Or as a tutorial there, this is a reaction between HCl with sodium bicarbonate. We'll be having sodium chloride, carbon dioxide, and water. And if you take a look at the board, we're having 2 tables of value. While we're having this table of values, on that day of examination, a tutor or teacher can decide to give different group different table of values. Are you with me now? In a class of 30 students writing the Waec, you can divide it into 2, having one group with a particular table of value and another group for a particular table of values. And back to what we have on the board. The first table of values, if you have to take a look at what you have here, the volume of acid used, so that will be volume of acid used equal to the first titer plus the second titer plus the third titer divided by what? 3. So now let's take a look at that. We have 23, this is the first titer value, plus 23.50 plus 23.55 divided by what? 3. So what are we going to have? 23 plus 60 plus 23 plus 50 plus 23 plus 55. So what are we going to have? We are having this, come closer, you can see, divided by 3. So we have 23.55 cm cube. This is the table of value. And don't forget that this particular practical, what we are watching today is likely corrections to the forthcoming examination. So now the next one, for the second table of value, for the first table of value we have 23.55 cm cube, while for the second table of value, so let's go, volume of acid used equal to the first titer plus second titer plus third titer divided by 3. So let's take a look at that. We have 23.40 plus 24.50, sorry, 24.50 plus 24 plus 24 plus 50 divided by 3. So we have 24.50 plus 24.50 plus 24.50 divided by 3. So at the end we have 24.50 cm cube. So guys, we have two table of values because in some schools, as I've said earlier, you can decide to choose on any table of values we have to use. So guys, now let's be making use of the first table of value. So with that, we can say our VA first table of value. So we have 23.55 cm cube. Then VA second table of value. So we have 24 cm cube. So guys, now let's go back to the calculation now. So guys, let's go back to the calculation now. So please don't forget that if you are to carry out the practical in the lab, by God's grace on Saturday I'll be showing the demonstration of what we have on the board. But before then, I have to drop this based on our subscribers that we are here to drop a video. So guys, back to what we are asked to calculate on the board. The first thing states that we have to calculate, they said, from your result and the information provided, calculate the concentration of B in mole per dm cube. So guys, I'll be making use of the first table of value, or I can decide to make use of the second table of value. So guys, I'll be going with this second table of value, and if you come across this video, you can choose between the first table of value or the second table of value, but I will be using the second table of value, which is the average volume of the acid used. So guys, the first one is concentration of B in mole per dm cube. Don't forget, this is our B, and if you observe vividly, we are given the value of A is equal to 0.10 mole per dm cube, but we are not given the concentration of B. So guys, for us to calculate this kind of equation, now back to this, the number of mole here is 1, 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 the number of mole here is what? 1. And this particular B is a base, while this HCl, we all know hydrochloric acid. So exactly now. So by doing that, we can say we have Ca, Va equal Cb, Vb equal Na divided by Nb. By doing that, I will advise you have to write out all your parameters, so if you have to calculate, you won't have any issues. So with that, so we can set our Ca is given to be 0.10 according to the manual. You can see we have here 0.10 according to the manual, and Va, which is the volume of acid used from that table of value, is 24.50 cm cube, and this is mole per dm cube. So guys, our Cb is what we are calculating for, because we don't know the value of the volume concentration of base used. That's concentration of B in mole per dm cube. So our Vb, our our pipettes can have two volume, either 20 cm cube or 25 cm cube. So we're making use of the 25 cm cube. In some schools, some teachers can decide to make use of 20 cm cube. So our Na equal 1, then our Nb is equal to what? 1. So by doing that, we have to make Cb the subject of formula. So let's cross multiply. So we have Cb, Vb, Na equal to what? Ca, Va, Nb. So the coefficient of Cb is Vb, Na, Vb, Na. So this, we cancel this. So our Cb, what is our Ca? 0.10 multiplied by our Va, 24.50 multiplied by 1. We have 25 multiplied by 1. So guys, let's check. So we said we have 0.10 times 24. There's a point here, please. 0.50 divided by 25. So 0.098 mole dm cube. So now, guys, we have our CB. So the next thing we have to calculate is concentration of B in gram per dm cube. So if we have to calculate the concentration of B in gram per dm cube, so you can say mass conc equal to molar conc multiplied by molar mass of B. Now, the molar mass of B equal to sodium bicarbonate. So our sodium is 23 plus 1 plus 12 plus 16 times 3. So is that, like I said, this will give us 48. You said 23 plus 1 plus 12 plus 48. So we have 84 gram per mole. And the molar concentration is this value we have here. Are you with me now? The molar concentration is this value we have here. So by then I said 0.098 times 84. So I said mass conc equal to, what's our molar conc? We have 0.098 multiplied by this. We have 84. So that will give us 8.23 gram per dm cube. So that is how you calculate the concentration of B in gram per dm cube. Note one thing: if you are given a question under this volumetric analysis, calculating for molar concentration, the formula for us to have molar concentration is equal to mass concentration divided by molar mass. And if you have to calculate for mass concentration, which is on the board, mass concentration is equal to molar concentration multiplied by molar mass. Is that clear now? So telling you guys that you are not only to calculate what you don't know, but you need to understand the concept of each formulas that are going to apply to it. So let's take the third one, concentration of A in mole per dm cube. If you have to calculate this concentration of A in mole per dm cube, you can say molar, you can introduce that formula I mentioned earlier, molar conc of A equal mass conc divided by molar mass of A. So looking at what we have on the board here now, you don't have to what? Stress yourself much, because with what we have on the board, we have our molar conc of A to be 0.10, and the molar mass of A is HCl, as I've said earlier. Molar mass of A equal to HCl. So we have 1 plus 35.5 and we have 36.5. So by doing that, for us to have our A to be 0.10 divided by 36.5. Are you with me now? Or we said 0.10. So guys, looking at what we have on the board now, our molar conc of A is 0.10. The molar mass of A is this. Now, concentration of A in mole per dm cube, no, it should be concentration of A in gram per dm cube, because if we are to multiply the molar conc times molar mass, we are going to have a mass conc. So this is concentration of A in gram per dm cube. So guys, when you cross multiply, you said you have mass conc of A, which is what? Gram per dm cube, equal 0.10 of A in mole per dm cube. Don't forget, Let's get the formula by saying molar conc of A multiplied by molar mass. So molar conc of A is 0.10 times 36.5. By doing that, we are going to have 3.65 gram per dm cube. So guys, now you can see the steps of how you can easily deduce your answers using the right formulas. Please, if you have to tackle any question given to you on that day of examination, read the question very well. On that day, you can decide to change this concentration of A to another thing. But when you understand the concept of what you are asked to calculate, you will find it easier to solve. So now, the last one is 4. I said volume of carbon dioxide gas produced at STP. So don't forget that at STP, volume at STP is equal to 22.4 dm cube. Are you with me now? And by doing that, so the number of mole of carbon dioxide is 1. So guys, now what is the volume, or what is the concentration of the B, which is the base? So you can set N equal to CB multiplied by VA divided by 1000. So our CB value is this class. Then the volume of the acid, it will be volume of the base, since we are calculating for the base. So the volume of the base is for the pipette is either 20 or 25. But since we have made use of 25 here we are going to have 25. So we can say the value of CB here is 0.098 multiplied by 25 divided by what? 1000. So let's see what we are going to have. 0.098 times 25 divided by 1000. 0.098 multiplied by 25 divided by 1000. So we have 0.00245 mole. So now for us to have this is 0.0245 mole. The next one we are going to have is, since we said we are looking for B, the volume of carbon dioxide gas produced at STP, which is the B, here's what we are going to do. Are you with me, guys? So that will be 1 mole of CO2. 1 mole of CO2 is equivalent to that is 0.00245 multiplied by 1. We still have the same thing. So now the volume of CO2 produced, so he said volume of CO2 produced, that will now be the value given here, the molar volume at STP, and the value we have here, that will be 0.00245 multiplied by 22.4 dm cube. So times 22.4 dm cube. So we have 0.0245 multiplied by 22.4 dm cube. So we have 0.0548. So we can easily say we have 0.055. So guys, don't forget to subscribe to my channel. If you have any question concerning what we have solved, don't forget I said earlier that this video based on alternative to practical. So on in few days, I'll be showing you guys the demonstration of both the volumetric analysis and the qualitative analysis. Thanks.